In part 4 of Sigrity Topology Explorer series, we have learned how to create and add SPICE models of DIM connector. We have seen the replacement of lossless ideal transmission line model with lossy or real-world models. In this video, I will talk about how to create a source synchronous topology and how to run sweep analysis to find out ideal design constraints. So let's get started. In the very first step, let's open part 4's topology in Topology Explorer 17.4, or you can download it using the link given in the description and open it in Topology Explorer. After opening the topology, we are going to copy and paste the existing topology for Data-Strobe. People who don't know, in DDR parallel bus system, data bits are synchronized with Data-Strobe signals instead of clock, and data toggle at rising and falling edge of Data-Strobe signals. To copy it, you have to first zoom out the topology and select by dragging your mouse cursor, Ctrl C and Ctrl V the topology. I'm just going to place it somewhere here. Then right click and click over done. After copying the topology, I'm just going to change few names or reference designators. So while simulation, we can differentiate between the components. So let's zoom in a little bit. And here, instead of control data 1, I'm just going to rename it control strobe. And similarly for dim data to dim strobe. I'm not going to change other reference designators as of now. In the next step, we are going to set up strobe driver stimulus parameters. To do that, first click on set analysis options. And here we have to select control strobe. So that will be the driver side of other topology. Now the reason is same, the data rate of this driver will be again twice of clock frequency because it's double data rate or DDR, and signal will toggle at rising and falling edge of the clock. So I'm just going to change it to 0.532 Gbps and number of bits will be again 532. Now in case of strobe signal, I'm not going to change the stimulus pattern to random. It should be 1010 pattern. Now in case of stimulus offset in nanosecond, we are going to put 0.94 nanoseconds. Why I've changed it to 0.94? So if you recall DDR interface, their data signal is center aligned with Data-Strobe. And we have switching on both rising and falling edge of that signal. That means in a clock cycle, every edge will be after each clock period divided by 2. And if you want to center align the data bits, it will be clock period divided by 4. So total offset we need to add is 1 by 266 MHz divided by 4. And if you'll calculate that, it will be 0.938. So that's why I'm approximately using 0.94 nanoseconds here. Let's close this first. Now in the next step, we are going to set up parametric sweep. To do that, you have to go to Tools and select Sweep Manager from here. Now inside the Sweep Manager, you have to select Sweep Type to SPICE models and select Parameters here. Now inside the Block drop-down menu, you'll get all the components that we are using in topology. First, we are going to select TL1 here. And here we'll get the value and parameters for TL1. And if I'll double click over length parameter, it will automatically shift it to sweep list. Now another parameter I'm just going to add in our sweep list is TL8. So let's select that as well and double click here. Now after adding all the parameters in the sweep list, we are going to put couple of values here, which will be minimum, maximum and step size. In this case, we are running sweep analysis for lengths. So our minimum length will be 2500 and maximum will be 4500. I'm just going to run it for 3 step counts. So that means the step size will be thousands for both cases. Now in the third column, we'll get all the combinations possible for these values and these step size. Once we have set up all the iterations, in the next step, we are going to run sweep simulations. Now here it will ask, you want to run for all the 9 iterations or not? In our case, we are going to run for all the 9 iterations. So let's click on yes button. Once the sweep iterations are done, you will get this report generator window. And from here, we are going to uncheck couple of options which is applicable for differential signals only. First is waveform quality. Then we'll click over Customize Report, and from here we are going to uncheck these values and then click on OK and Generate Report. Once the report is ready, you can just maximize the size of these reports and these waveforms. I just want to show you a couple of waveforms. For example, eye quality report. So let's click on that eye quality report link and it will direct you to this table. And here we'll get the information. The worst value or the worst length for this topology is 166.2. And if you wanted to see the waveform for this, you have to just click on DQ1 and just maximize this SI viewer. And after maximizing it, you can evaluate the value of waveform. Similarly, you can check the plots for delay reports. Here I want to show you a couple of things. So firstly, I'm just going to uncheck this and go to the 9th combination and plot for DQ1 data and DQ1 strobe. The purpose of all these combinations, we need to find out best setup and hold time or setup and hold time balance for different lengths, and that will be the preferred length for constraint. Alright, so I'm just going to close it and you can save the topology. You can download all the project file from the link in the description and play along with the values. For more tutorials, visit us at resources.emaeda.com and don't forget to like and subscribe our YouTube channel.